G'day guys, I've got a calculus question for you today that was taken from a high school maths exam. This is quite a tricky integration question, so I thought I would sort of share it with everybody. So let's get to it. The horizontal line y equals m intersects the curve y equals 2x minus 3x cubed in the first quadrant as shown. Now we're asked to find the value of m such that the area of the shaded regions are equal. Now it gives us a hint that we have to begin by letting a, m denote the point farthest to the right where the curve y equals 2x minus 3x cubed and y equals m intersect. Okay, so this point here, we're going to call that a, m. Cool. So we've got two areas here, guys. Now these can be denoted the area between these two curves if I get an integral of this function and subtract this function. Now the form of this integral is going to be, well, the integral from 0 to a of f of x minus g of x dx. Now for these two to be equal, now let's say I let the cubic be the f of x, the top function. The area under the curve for this part here is going to be positive, and the area under the curve for this part would be negative. Now when I do the total integration between 0 and this point a here, if this is positive and this is the negative and they're equal, the whole integral will have to equal, you guessed it, 0. They'll have to cancel each other out. So what I would do if this was my exam, I'd then go, well, I'm going to let f of x equal the cubic, 2x minus 3x cubed, and I'm going to let g of x equal the constant m. Great. So what I can do then is let's just write down our integral again. So we have the integral from 0 to a of 2x, so we've got f of x, so that's going to be 2x minus 3x cubed. And then we're going to, from that, take away m. Then we obviously have dx on the back. Cool. So let's just do this integral. So we're going to have the integral of this is going to be just x squared minus, what have we got, 3 over 4 x to the power of 4 minus, now this is just going to be, because it's a constant, if we integrate a constant, we just get mx, and this has to be integrated between 0 and a. Great. So again, we can just go about evaluating this integral. So we start with our upper bound, insert a, so we have a squared minus 3 over 4 a to the power of 4 minus m times a. From that, we're going to subtract everything with 0. So let's have a look. We've got 0 squared, 0, 0 to the power of 4 times 3/4 is still 0. M times 0 is, you guessed it, 0. Now, all of this has to be equal to 0. Great. Now, as you can see, guys, this particular formula, let's just clean it up. I'm just going to have my a squared minus 3 over 4 a to the power of 4 minus ma equals 0. So I've just gotten rid of that 0 there. It's not really that important. And now you can see we have two unknowns. We've got m and we also have a. So what we're going to do is the next step that I think a lot of kids would have trouble with understanding, or not understanding, but picking up on the fly in an exam, under the pressure cooker situation that is an exam, is recognizing that this point am that they give us in the hint, not only is it our upper bound of our integration, but it also lies on the curve y equals 2x minus 3x cubed. So I can sub in these 2 points into this function. So if this lies on that, it's perfectly reasonable for me to say, well, therefore m has to be equal to 2a minus 3a cubed. Now from there, guys, this is basically a simultaneous equation style thing. I can get this function that I've just derived from understanding that that point is on that curve, and I can substitute it for m in here. So let's do that. What do we have? Well, I'm going to go, this is going to be equal to a squared minus 3 over 4, a to the power of 4. The next thing, rather than writing m, I'm going to write this a here. So let's just get my a that I've already got there, and I'm going to multiply it by 2a minus 3a cubed. And all of that has to be equal to 0. So we then go about multiplying out our brackets. A squared minus 3 over 4, a to the power of 4, minus 2a squared, minus 3a to the power, minus, almost made a mistake, plus 3a to the power of 4 equals 0. Now guys, from here it's basically algebra. We're going to combine our like terms. We have 3a to the power of 4, which when I take away 3 quarters a to the 4, well 3 in terms of quarters is 12, 12 minus 3 is 9. I'm left with 9 over 4, a to the power of 4. Then I have a squared minus 2a squared, so that's going to be minus a squared equals 0. From here, just get another arrow going. You can see a sort of a trend sort of appearing here. I'm going to factorize this. So factorize it by a squared. 9 over 4, a to the power of 2 minus 1 equals a 0. From here, guys, I can use my, well, not mine, but I can use the null factor law. So I can say, well, that a squared has to equal 0, which obviously means a would have to equal 0. Not really what we're thinking is going to be over here. Or 9 over 4, a squared take 1 is equal to 0. So from here, we can take the 1 to the other side. So we have 9 over 4, a squared is equal to 1. We can then times by 4, divide by 9, and then square root it. So we can say, well, a is equal to the plus or minus square root of 4 over 9, which is equal to plus or minus 2 over 3. Cool. Now, we can write a little love message to the examiners to let them know that we're still thinking clearly. We can say that as a is greater than 0, comma, this a value must equal just regular 2/3. Cool. So from here, guys, I then have to figure out what my m value is. Now, what we derived earlier here is a function which gives us m in terms of a. So all I'm going to do from here is just enter in my a value into this function here. So finally, I've got m is equal to 2 times 2/3 minus 3 times 2/3 cubed. Now this is going to be equal to 2 times 2/3 is 4/3 minus, we've got 2 to the power of 3, 3 to the power of 3, so that's going to be 8 over 27. 8 times 3 is 24. Now from here, this is going to be equal to, in terms of 27, we have to times by 9, 9, we have 36. Which is equal to 24 over 27, taken away from 36 over 27 is 12 over 27, which is equal to, divided by 3, 4 over 9. So we can say, hence, comma, m is equal to 4 over 9. Because of my crazy working out, I would probably put a nice little box around this so the teacher understands where my answer is. Maybe sort of put a few arrows at it, if just to ram the point home. But as you can see, guys, there's a few different things in this that you have to be able to grasp or implement to be able to answer this question. You have to understand that for these two shaded regions to be equal, if I do like an f of x minus g of x style integration over this integral domain, I'm going to get 0 because the negative and the positive will cancel each other out. I then also have to understand that once I've got to here and I have two variables or two unknowns, I then have to go to this boundary point a comma m and realize that that also lies on the line y equals 2x minus 3x cubed. If I know that, I can come up with a function which gives me m in terms of a, which I can then substitute into this function of two variables and sort of plop out a function of just one variable. And from there, I'm just using algebra, making sure I don't screw anything up, and I get to a. From a, I can plonk it back into this function that I found, which is m in terms of a, make sure I still don't screw anything up with my fractions, and I pop out this, hence m is equal to 4 over 9. So the examiner in his comments said that this was one of the most poorly done questions that he's seen in a long time. It's only worth 5 marks, so I can see that a lot of kids would have been a bit skittish if they didn't understand exactly how to do it straight off the bat. But if you've seen a question like this before, it's quite easy to just go straight through it and get it. You just have to understand where to go first. So I hope that video helped, guys. If it did, please give it a thumbs up and subscribe to my channel so I can get my sort of maths help videos in front of as many eyeballs as possible. I've got lots of other maths videos, so you can check out my back catalogue, and if any of them help, well, that makes me happy. But until next time, guys, the only way to get better at these is through practice. Keep banging your head against the wall until the wall falls down. But until that time, guys, I hope you enjoy your maths, and I'll see you soon.